हो गई.
अवघड नाही सगळं सोपं आहे. हा हा
अभी तक मैं ही ज्वाइन किया
हो
सर.
चालेल ठीक ओके अरे
Rishi, are you going to the lectures? Rishi, can you hear me?
Yes sir.
Are you going to the lectures?
Sir, I haven't seen all the lectures because I was doing other MATLAB stuff also which ma'am had given. So I did not go through all the lectures, but few of them I saw.
How are you feeling? Are they difficult or are they feeling like a revision to you?
Sir, it's type of a revision only. Some of the questions, I mean, some of the concepts I wasn't recollecting, but now I can uh, recollect them properly.
Okay. Let us wait for some more time. Let others join.
Yes, sir, sure.
Deepak, are you finding the lectures difficult or easy? Or which year are you in, Deepak? Are you a first year student?
Sir, I am fourth year student. I find question solving is hard type, let moderate, but lecture
Okay, so
is
you're
so
preparing for
cool.
GATE?
Uh,
Are you preparing for GATE? I mean, why are you in this course?
no,
That's
no,
what I'm
sir. I
asking.
am preparing for a exam.
Okay, exams. Which college are you from?
Uh, IIT MGPRU Bareilly, Uttar Pradesh.
Bareilly. Okay. All right, let others come. We had two questions left from the last class. See, my whole point of taking these so many networks is you will learn many things in this fundamental course, okay? Many ways of solving circuit. But your thought process should never be like how to apply certain theorem or a certain method in a network. Rather, it should be the opposite. It should be like look at a circuit and then decide which method will be the easiest to solve this circuit. So that's why in these cases I do not what to say come with a conventional way. We try to see how easy we can make. My philosophy is I try to reduce variables as much as I can so that I have to solve less number of equations. Sometimes that is not possible. So anyway, um, in today's class, we have several complex networks which we will have to solve. So I would expect that you will solve the equations for me because I believe equation solving is a trivial thing, has nothing to do with electrical engineering, but still we have to do it. So I have the answers, but I want you to do it in an interactive way so that you can get a feel that you're also doing this problem. Say, let us look at this network. Okay. Now see, there are several ways we can go for mesh, we can go for node, but you see we have current sources here and all. What is the question? Let us see first. Power associated with the dependent current source. So how much power this one is delivering or absorbing, we have to find out. So you see, if you look at these two nodes, this node and this node, then you are almost touching the whole network. So this circuit, it looks like that node analysis will be easier. Okay. So, but these two node voltages we do not know. So we have two unknowns. Let us call this one as Vx. Let me write it away. And this one I will write Vy. Okay. Now at X node, I will write the node equation. Node equation is basically um, KCL. It will all about applying KCL. Now, okay, one more thing. When I write Vx, Vy, it means with respect to some ground, some point whose potential we have assumed to be 0. It can be anything, any point. But for us, we will take this one as 0. So it is easier to interpret the circuit. So if that is 0, then this point is 25 volt. We know. Rest we do not know, we will start. So what we will do is we will write it as summation of all the incoming currents to be 0. You can write the other way also, summation of all the outgoing current as 0, or you can write it as summation of incoming equals summation of outgoing, whatever, it doesn't matter, everything is the same. But make sure that you do not mess up while writing the incoming and outgoing direction. So to make sure that you do not mess up, what I would suggest is keep a convention that you write summation of incoming as 0, or maybe summation as outgoing as 0. Okay. So this one will start as, I will write say summation of incoming as 0. Now Vx, there are 4 branches associated with Vx. So this is the first one. Some current is coming from here. So how much is that current? So it is incoming. So we have to write 25 minus Vx by 3, right? Again, this one incoming. So plus 0 minus Vx by 3 plus incoming. So Vy minus Vx by 1 plus this incoming 3i1 equals 0. Okay. Now what we see here is we are getting 3 unknowns. Vx, Vy we took, and one unknown is still present, which is I1, which was given in the question. So we can write some relation between them. Anyway, we'll look at it later. If this is for the X node, for the Y node we can write similarly. So how much, say from here 5 ampere current is coming. So 5 we will write. 3i1 current is going out. So minus 3i1. Okay. So minus 3i1 current is coming in. Similarly, 0 minus Vy by 2 plus Vx minus Vy by 1 equals 0. 2 equations, and we have 3 unknowns. So one more we have to write. See, we can write from here. If this is 25 volt here, if this is 25 volt here, and I1 current is flowing, so there is a voltage drop of 3i1. So what we can write is one more equation. Vx is 25 minus 3i1. Or let us write it in this fashion. It will be easier because we already have 3i1 in those equations. 3i1 is 25 minus Vx. So these 3 equations we have, equation 1, 2, and 3. So what you can do is 3i1 here, you can replace here. You will get 25 minus Vx, and you can replace here. Can you solve this equation and tell me the answer? Doing right? Then I won't do. Are you doing? Okay, so I have a solution. You do it and verify later, or maybe if you are doing it now, then that else is fine. You should get VA equals 16 volt, not VA, there's already VA. Vx equals 16 volt and Vy is 8 volt. And if it is so, then what we have is Vx is 16, so 9, so I1 is 3. I1 is 3 ampere. So basically the current that is flowing here is 9 ampere. Now we have to find out the voltage. How to find out the voltage? Vx is 16 volt and Vy is 8 volt. So this is 8 volt. So definitely the power associated is 72 watt. 9 into 8, 72 watt. You tell me whether the power is being delivered by the source or being absorbed by the source. Can you guys hear me? Can you hear me?
Yes, sir.
Can you tell whether this 72 watt power is being absorbed or delivered by the source?
Delivered.
How do you know it is delivered?
The independent source at the output it is so
No.
it is that's why it is.
One second, I couldn't hear you. Not the independent source, the dependent source. Dependent source, 9 ampere, 8 volt.
Yes, of course.
Then why is it? You said it is delivering. Why do you think so? We discussed these things, that if the current is leaving, positive current is leaving the positive voltage terminal, then the power is delivered. It's delivering. Is it clear, this question? We'll move to the next. Voltage source in ampere. So I have to find out this current. So this also looks like a node voltage problem. We'll take these 3 nodes. Can you tell me the equations, any one of you? What should be the node voltage equation at X? Rishi, can you tell me? Node voltage equation at X?
Yes, sir.
Right. Three branches. Tell me one by one. This one we take as 0. Rishi, are you writing?
So just a minute. So you are not audible.
Okay, let me write and check if it is matching with yours. So I will write as currents going out. Deepak, can you tell me the equation for node Y? Deepak, am I audible to you?
Yes sir, I have urgently work, तो मैं sometimes के लिए बाहर गया था sir. I am writing now, just now.
Can you look at the circuit and tell what should be the first? Take the branches one by one.
Take the branches.
You know how to write node equations?
Yes sir,
Last
yes sir.
last problem you saw this problem when I was solving this?
Yes sir, I I I hear in whole the process and I understand last problem.
Okay, so then what should be the node equation at Y?
Yes sir, I tell.
Rishi, you want to try?
Sir, Vy minus Vx by 1 plus.
Okay, Deepak, you see if it is matching with yours. You will tell the next one. You are saying Vy minus Vx by 1. So you are considering about current going out. Okay?
Plus.
Plus.
Yeah. Vy minus Vz by 2.
Okay.
Vy by 20.
Okay.
And Vy by 15. That's it.
Then,
Equal to 0.
okay, Deepak, you tell me the Z node equation.
Okay, sir. Shall I speak?
Go ahead. Tell.
Vz minus 170 upon 4 plus Vz minus Vy upon 2 plus Vz upon 47
Equals.
equals 0.
Okay. So anyway, now we have three equations and three variables. We can solve it. I'm not going to solve it here. It will take a lot of unnecessary times. I have the solution. I will simply write the equations. Okay. Make sure that you can solve these things by you can solve this obviously, but since Deepak said he is preparing for competitive exams, make sure that you can solve these things fast. Okay, so what we have is Vx as 50 volt, Vy as 60 volt, and Vz as 94 volt. This we have. Now the question is determine the current delivered by the voltage source in ampere. Now we can find out the current I. I will be 170 minus Vz. Vz is 94 by 4, which is how much? 76 by 4, 19 ampere. This one. Okay, well, these were the two problems that were remaining from the last day's class. We will go for today's problems. All right. Find the value of R in figure 1 such that the power supplied by the voltage source to the network is same as the power supplied by the current source. So if you take the voltage across what we have is 5V equals 18I. It is V equals 16I. This one equation we have. Okay. Let us see if we can do this without using node or something. So if you have V like this, then for 2 ampere is 5 ampere is flowing, so there is a 10 volt drop here. So this is at 10 plus V. This voltage is 10 plus V. Okay. Now if this is 10 plus V, then the current going down in this path is 10 plus V by R. Now 5 ampere current was coming this way, of which 10 plus V by R goes out. So the current that is flowing in this path is 5 minus 10 plus V by R. Now 80 volt is there across 20 ohms. So Just a second. Is this V plus 10 or V minus 10? V minus 10. You guys did not say anything. Voltage is dropping. Plus V minus 10. So all are minus. Minus 5 minus 10 by, of which 4 ampere goes out in this branch. So what we are left with in this branch is 1 minus V minus 10 by R. Now we also know that the current through this branch is I in the other direction. So from here we can write, basically KCL we are writing 1 minus V minus 10 by R equals minus I. This equation we have here for this node. Now, okay, we have 3 unknowns, 3 variables. We will need one more equation. Okay, we can do, we know that voltage at this point is 80 volt and voltage at this point is this much current is like this. So we can write V minus 10 minus 10 times 5 minus V minus 10 by R equals 80. Is it clear how I wrote this equation? From this branch. From this branch I could write the equation. So from this equation what we can write is V minus 10 minus 50 plus 10V wait, minus 100 by R equals 80 . Okay, let us not multiply this. Let us keep it like this. We have something here. Okay. So what we have is V plus 10 times V minus 10 by R equals 140. No, yeah, 140. Let's say V minus 10 by R is I plus 1. From here we can write V minus 10 by R is I plus 1. That we will put. Also from this equation we will write V as 69. So if I write V as 69 from equation 1 and if I write this as I plus 1 from equation 2, we are left with only I in this equation, so we can solve it. So what we have is 69 plus 10I, 26I is 130. So I is 5 ampere. So if I is 5 ampere, then V is 80 volt. So basically what we have is voltage drop across 5 ampere source is 80 volt and current supplied by the 80 volt source is 5 ampere. Okay. We have this. Now we have to find out the value of R. Value of R we can find from anywhere, say from equation 2 itself. From here itself we can find the value of R. We simply substitute the values of V and I. So what we have is V 80 minus 10 by R equals 5 plus 1. So R is 70 by 6. This will be 11 point something. Is this question clear or the solution clear? Okay, I hope it is clear. We'll go to the next question. This one is clearly, we will have a lot of problems like this today. Okay, I will not solve all of them, but I will write the equations for all of them. You guys make sure that you have no doubt in how to write the equations. Then it's all about solving the equation, which you can do. Determine the power associated with the 10-volt source, this one. So basically you have to find the current here. Current we have to find out. So same thing we will do. We will find Vx and Vy. Once we know Vx and Vy, we can find out the current. So if this is Vx and Vy, what we have here is Vy plus 10. This one is Vy plus 10. Okay. Now we will start writing the equations. So what is the equation at node X? At node X, let us consider the current is going out. So it is Vx minus 20 by 4 plus Vx minus Vy minus 10 by 2 plus Vx by 4 plus Vx minus V. This is equation number 1, and for node 2 or the other node we have similar thing. Now as I said that these are all with respect to this, so this is at minus 30 volt. So for node Y we have Vy plus 30 by 6 plus Vy by 6 plus Vy minus Vx by 2, sorry, plus how much? Okay, we have to do it now the other way around. Had the 10 volt source, it's the same thing whether the 10 volt source is here. No, we need not think so much. We are simply finding out the current Vy minus Vx going out. So we can simply write this voltage minus this voltage. Vy plus 10 minus Vx by 2 equals 0. This is equation 2. Right? We have two equations and two unknowns, so we can solve this. If you solve, the answer will come as Vx 4 volt, Vy minus 4 volt. This we will get. Now if Vy is minus 4 volt, then the voltage here is 6. And Vx, as we found out, is 4 volt. So this is high voltage, this is low voltage. So 2 volt drop across the resistor in this fashion. So 1 ampere current will flow. So the power is definitely 10 watt delivered. Okay.
Sir, how come 10 watt power?
This is 1 ampere current through this branch, and it's a 10-volt battery,
Yeah.
and the current is leaving the positive terminal, so delivered.
Okay, sir.
Okay, any doubt here?
No, sir.
All right, we'll go to this question. Same thing, we have several nodes like this. We have to see which nodes will be useful to us. See, we have 3 nodes basically. This is one node, this is one node, and this is another node. We have to find out I2 minus I1. Right, these 3 nodes we have. Can you understand that this node that I encircled and this node, they are actually the same node. They are not different nodes. Do you understand that? Because they have the same voltage. They have the same voltage. Why so? Because there is no element between them. It's a short or a wire. So they are the same nodes. Also, I will encircle 2 more nodes with green ink. Once you can see those nodes, you tell me, are these nodes? Can we call these nodes?
Yes, sir. These are nodes.
No,
Green
these are
circle.
not nodes. You see, a node is where
Sorry, sir.
at
They are
least 3 elements are
element present.
connected. A node is where at least 3 elements are connected. This becomes a node. But here it is drawn like this. You see, I could have drawn this thing like this. Instead of drawing this rectangle, I could have drawn the wire like this.
Yes, sir.
Okay. So these are not nodes. Had there been another element here, say like this, then this becomes a node. Then this
Yes.
becomes a node. Okay. So what we were discussing, we'll remove this. We have 3 nodes. This, and this. I'm sorry. These 2 are same nodes, I said. So these 3 nodes we have. See, if I take a voltage VA here, I cannot determine the current that is flowing because there is no in fact, I know the node voltage here basically. This node voltage I already know. This is 30 volt. This is 0 volt. So this I already know. So I need not write a node equation there. What I do not know is this Vx here and Vy here. These 2 we do not know. So we can apply node equations. You can write node equations and solve the circuit. Okay, we have to find out I1 minus I2. Let us forget I1 minus I2, I1, I2 now. Solve the circuit, then we'll find out how much I1 and I2 are. Now we will start with node X. Node X. So how much current is going out? Vx minus 30 by 1 plus Vx by 2. What I am doing how much current is going out. So 20 ampere current is coming into this node. So I have to write minus 20 and Vx minus Vy by 10. This comes out to be 0. This is one equation. And other equation in hand is Vy. I'm doing how much current is going out. So 10 ampere current is going out plus Vy by 4 going out plus Vy minus Vx by 10 going out. This is equation 2. Any doubts in the equations?
No, sir.
Okay. So if you solve this, you will get Vx as 30 volt, Vy as minus 20 volt. Okay. Now if Vx is 30 volt, then definitely I1 is 0 because this other node was also 30 volt. And if Vy is minus 20 volt, so there is a 50 volt difference. So definitely I2 is minus 5 ampere. 5 ampere current is flowing in this way. So I2 minus I1 minus I2, which is 0 minus 5. I2 is minus 5, okay? 5 ampere. All right, we'll go to the next question. If there should no, is there any doubt? It's the same question as before. Okay. This one. This circuit looks like mesh operation will be easier. What is the question? Determine the value of I naught. We have to find this current I naught in this branch. There are several loops. So we can take loop current. You know how to take loop current? You can assume any current like this. Say, if I assume this current to be, say, I1 in any direction, doesn't matter which direction you take. Do not think that you're taking this direction only. I'm intentionally drawing the loops like this. In textbook, you will see they only draw rounds. Okay, let me change the color. This one, in textbook, you will see they write like this, but I am intentionally drawing them like this. I will see why. Okay. This one is I2 and this one is I3. So if I start this other outer loop I'm drawing, this one, okay, I will draw it blue. This one is I3. So I1 is flowing in this way and this way. I2 is flowing like this and I3 is flowing like this. Okay. Now in the loops we will apply KVL. KVL also you can write in any direction you wish. We will write along the current in the same direction the current flows. We will write. So let us take the loop I1, this one. We call this loop 1, call this loop 2, call this loop 3. This one we will take. Wait just a minute. We will take loop 1. Now loop 1, what we have is, now we will understand why I drew the current like this. Let us start from here. Let us start from this point. Doesn't matter where to start, I will start from this point. So there is an increment of 25 volts. So I will write 25. Then a drop of 5 ohm. I1 current is flowing through 5 ohm. So minus drop. Minus 5 I1. Now we will come at the 20 ohm. This resistance that is put vertically. This 20 ohm resistance, you see, how much current is it flowing along the direction, along the red curve? Along the red curve, it is carrying I1 minus I2. Can you see the green arrow? It is pointed upwards. So along the red curve, if you see, why I am emphasizing on along the red curve, because I will write it as a drop. Okay. So if I want to write it as a drop, I have to do it along the red curve. Along the red curve, the current is I1 minus I2. Okay. Similarly, on the 5 ohm resistance, we have again minus 5 I1 minus I3. Is this clear? Okay. Directions are very important here. In what direction you assume the current through a resistor, the same direction you should assume the drop. Do not mess it up. Okay. Then we will write the equation for node 2. Node 2, let us start from here. Okay. Then there is a drop of 25. So minus 25. Oh, we were writing along the current, right? We were writing along the current. We'll write along the current. So first we will go to this 5 ohm resistance that is below that node. So we'll follow the green curve. So if we follow the green curve, it is minus 5 I2. We are following the green curve. So minus 20 times I2 minus I1. Again minus 5 times I2. Oh, I made a mistake here. Did you not notice? Through this 5 ohm resistance, there is I3 also in the other direction. So it should be minus 5 times I2 minus I3. We are going in this way. So minus 5 times I2, this green I2 minus blue I3, this one. 25 I2. And then there is an increment of 25 volt. This is 0. While writing the loop equation for loop number 1, we were going vertically downwards. I should say vertically. We are going downwards from the top node to the bottom node. And while writing equation for the loop 2, we were going down to up. That's why the directions are different. So be very careful while writing these equations. if you have a resistance like this and if you have a current like this, then the voltage is like this. If it is R, then IR. It doesn't matter what is the actual direction of current. If the actual current is the other way, after solving the equation, I will come as negative. So don't bother about that. If you are assuming the current to be in this way, the voltage that you have to take is in this fashion, IR, in this polarity. It's very important. Okay. Now we are left with the loop equation of loop 3. We'll start from here and go along the curve, blue curve. So there is a drop of minus 10 I3, means drop of 10 I3, so minus 10 I3. Then a rise of 50 volt. We are going along this now through the 5 ohm resistance. We are going through this one. So we are considering drop. So minus 5 times I3 minus I1. You can see in front of your eyes through this resistance. In this side, it is blue arrow is in this way. I1, the red arrow, is the other way. So it's I3 minus I1. Again, it is I3 minus I2 through the other resistance, 5 ohm resistance. Zero. So the most tricky part about these circuits are to what to say, this equation, how you write the equation. Do not mess up the polarities. It's all about writing these equations, then it's only solving. We can easily solve. Okay, any doubt about how to write these equations, how we got these equations? Any mistake you found anywhere?
No doubt and not found mistake.
Okay, then we'll go ahead. Once again, I will assume that you can solve this equation. These are linear equations, three equations, three variables. You can easily solve. Substitution, determinant, whatever you want to do. Make sure that you practice one method again and again. For competitive exam people, I'm saying, like, I'm pretty sure you guys can solve this equation much faster than me. Okay. So if you solve this, what you will get is I1 5 ampere, I2 5 ampere, all of them are 5 ampere. I have a solution, from there I am writing. I did not solve this. I3 5 ampere, all of them are 5 ampere. Now you see, this I1, I2, I3, they are not real currents. They are real currents in some branches, but they're actually loop currents. So let us now clean up the circuit and write the actual value of currents everywhere. Okay. So if this is I1, I1 is 5, all of them are 5 amperes. So I will now write the currents in red. So this is 5 ampere because 5 ampere was flowing. I1 is 5 ampere, they have said. And you see, in this 20 ohm resistance, there is downwards 5 ampere, upwards 5 ampere. Basically, the current through this is I1 minus I2. So I1 minus I2 is 0. So what we have, this I0 is 0 ampere. Similarly, here also we have I1 minus I3 in this resistance. So here also we have 0 ampere in whatever direction you show. 0 ampere. So if this is 0 ampere, the 5 ampere that was coming, so basically I2 is going here. Once again, I2 minus I3, 0 amps. So no current flows through this branch also. Zero amps. So the whole 5 ampere current has to flow through here, which is also true because this was I3. 5 ampere comes. Okay. Okay, did I make a mistake by writing off or erasing the loops? I shouldn't have erased the loops, right? I will give it as a solution to you guys. Okay, have you understood how I wrote these currents? Then I will undo and bring back all those things.
Yes, sir. Understand how I take I1, I2, I3 and write equation and get
Okay,
current.
then I will undo everything and make sure the loops appear, because when you will get this thing as a solution, you'll be able to understand if you don't have the loops. Okay, only this much undo I can do, rest I have to do by myself, not a problem. So this we assumed as I1. When you are solving these equations in textbook, as I told you, you will see they only draw just a circle they show, but you draw them along the component, so that when you are writing the currents in the component, you do not make a mistake about the direction. Right, it all depends how you take I1 and I2 and I3. See, I took all of them in this fashion, but I could have taken I2 in the other direction also. In that case, the current through the 20 ohm resistance would have been I1 plus I2, and I will get I2 as minus 5 ampere. It would come like that. So it hardly matters, but make sure that you are adding up or subtracting the currents properly. So it's better you draw the loops like this. Okay, so what we got finally is 0 ampere. Kind of a balanced, like Wheatstone bridge. I'm thinking one thing. Okay, any doubt?
No, sir.
Okay, we'll go to the next question then. This problem is interesting. Before we go into this problem, there is one term in this problem which you may not know as of now. Means you know the word, I think, which is efficiency. What is efficiency of a system? Do you know?
Output upon input multiply 100.
What is output? What output current?
Yes, sir. Depends on which machine
Mm,
efficiency.
no. Okay, we'll see.
I the
So
formula.
suppose, sorry, go ahead.
No, sir.
I can't hear you. Your voice is very feeble.
Sir, I tell roughly formula, not any for machine.
Not for machine, anything, any system. Okay, we'll see. So say we have a system, anything. I don't know what it is inside, some kind of black box. But what we know is this system is taking some power. So there is some power input to this system. Okay. Some power input to this system, Pi, and it is doing some work or some output power we are getting out of the system, which is P naught. Now, this system, if this system is ideal, that is, it's a lossless system, then P naught should be equal to Pi, or yeah, Pi. But no system is lossless. There is always a loss. So what is happening is this Pi is coming, and there is some loss in this system. I will write it as PL. So we are giving energy Pi to the system. Some power is lost, and rest we are getting as output. So by energy conservation, we can write that input power is loss plus output power. Okay. And efficiency we um, denote by this Greek letter. What is this?
Eta.
Eta. Efficiency we write as output power by input power. So P output by P input. Okay. Now, if you want to express this efficiency in percentage, you can multiply it with 100 and you will get something. Or if you can simply keep it like this, you will get something that is less than 1. In the range of 0 to 1, you will get. So 0 to 1, you will get. Okay. Now, what I said is this is for any system. At the end of towards the end of this course, you will learn, I think, 3 electric machines, 1 static machine, transformer, and 2 rotating machine, induction motor and DC motor. And in DC motor, you will DC machine, and in DC machine, you will see that the same machine can be operated as a motor and also as a generator. Okay. So what does a motor do? Suppose, okay, induction motor can also be used as a generator, but that will not be taught in this course. So you have a motor. So what does a motor do? Motor takes power which is electrical in form, and it gives out the power which is mechanical. So in case of motor, if you have to write the efficiency, you have to write the mechanical output by the electrical input. The formula is the same. So what is the output of a motor? The motor is running at certain speed omega, and it is delivering a certain torque tau. So if you multiply omega times tau, omega and tau, if you multiply, so what you get is the power output. Also, the input is voltage and electrical. So some voltage and some current, that is the input power. So this is how you calculate the efficiency of a motor. Similarly, you will get for a generator also. Say if you have a generator, this the same DC machine. Now if you are operating as a generator, it is the opposite thing. Generator, we drive by something, right? A generator is run by an engine, say. So the input power to a generator is mechanical, and the output power to a generator is electrical, because it is generating electric power. And similarly, you can find out the efficiency. And for a transformer, let us say, what is the input and what is the output? Tell me, you guys have studied transformer. In what form? For motor, generator, research, mechanical. Yeah, go ahead. Both are electrical. Both are electrical. Now, there are several ways of writing efficiency. One way, as I wrote, is P output by P input, which is a definition. Now, sometime people, it depends on what all information you have from the problem. It doesn't matter. So P output can be called as P input minus P loss by P input, which comes out to be 1 minus P loss by P input. It can also be written as P output by P output plus loss. In several ways you can write. It's all the same thing. It's about the uh, efficiency equation and the energy conservation equation. All right. Now we look into this problem. This problem actually, they have given a voltage divider circuit and there are 3 load resistances connected to the voltage divider circuit, and they have asked you to find out the efficiency of the circuit. Efficiency of the circuit at the current operating condition. I discussed this thing at the in the very first or second class, I think, that these things are non-linear. You change one thing, everything changes in the circuit. Okay. That is not the definition of non-linearity, by the way. Okay. We look into the question. In the voltage divider circuit shown in figure 5, a 24-volt battery is used to supply resistive loads at 24 volt, 18 volt, 12 volt. So you understand these things. These are called wipers. Wiper means you can move, although they are shown as lumped parameters here. You know what is lumped parameter? So you have a long resistance like this, and one wiper is present here. Wiper means you can move it. There is a knob outside which you can rotate and this will move this way, this way. And another one here. This also can move both way. Now, so from here to here, the resistance is distributed. It's not at one place. But when we draw, we draw like this. One resistance, one resistance, one resistance. This is called lumped parameter. Say for a motor, okay, say the ceiling fan above your head. It has a long coil, very long wire. If you dewind and keep the wire, straighten the wire and keep it, is a very, very long wire. So the resistance that you measure, that comes out to be, say, 0.3 ohm. So when we draw the circuit, we simply draw a resistance of 0.3 ohm, but it's actually distributed throughout. We cannot tap anywhere in bit. We can, but it's not accessible from outside. So the whole thing we draw as one parameter. It's a lumped parameter. Okay. All right. So what they have drawn here are the lumped resistances of the potential divider R1, R2, R3. The wipers are placed here, and the loads are such that they are currently getting voltages of 12 volt, 18 volt, and 24 volt across them, and drawing the currents of 8 ampere, 4 ampere, and 2 ampere from the potential divider. Now the question is, if the current flowing through the resistance is 1/15th of the total divider current is this, I, let us say. Determine the efficiency of the voltage divider. Now this is I. Go ahead.
The screen not visible.
My screen is not visible.
This is at the initial screen means what you say that it is not written on the screen.
Oh, I think there is a lag. There can be internet issues. Can you see the blue and red resistances I drew right hand side?
Yes.
Yes, sir.
Okay, after that I did not write anything. I have only written one blue I current in the circuit, left hand side. Can you see that? I will encircle that. This one, can you see? There were some messages. Okay, someone answered during efficiency discussion. Can you see the input current I that I have drawn in blue ink?
Yes, sir.
Okay. So what they have said is the current through R3. I think you can see R3. R3 is at the bottom here. I will use red. Here. That is 1 by 15th of the total divider current. So then this is I by 15. I will remove the wipers, otherwise they are decisive. I by 15. So I by 15 is definitely in this direction, has to be in this direction. So I by 15 and 2 ampere is going out. So this has to be 2 plus I by 15. Again 4 ampere is going out. So this current has to be 6 plus I by 15. Now if we apply KCL here, what we have is I, that was the total current coming in, is equal to the total current going out is 8 plus 6 plus I by 15. So 14I by 15 is 14. So I is, sorry, I is 15 ampere. Okay. Now if I is 15 ampere, we know this one is 15 ampere. Then what is the input power to the system? The input power to the system Pi is 24 times 15 watt, which is this much input. And what is the output? Output is, what is output? Output is nothing but the loss in these three resistances, in the load resistances. The power, we should not say loss in load resistance, we should say power consumed by the load resistance. R4, R5, R6. So what is the power consumed in the load resistances? We know the current and voltage to all of them. So it's 12 into 2, 24. 18 into 4, 72. Is it 72? Yes. Plus 24 into 8. How much is it? 192, is it? Maybe. Now let us add these three up. 24 plus 72 plus 192 gives us 288. 288 watt. So the efficiency is 288 by 360. How much is it? So 288 by 360, if I do, I get 0.8. So it is 0.8. You can write efficiency as 0.8, or the same thing you can call as 80%. This one. Okay, tell me, any doubt in this question? After this, all the questions are boring. Same thing. Node and node and node.
No, sir, interesting, but learning is important.
Could you please speak louder? I can't hear you.
No, sir, interesting question this.
No, no, this one is interesting. I think I am saying after this. Again, we will go through nodes and all.
Yes, sir, understand.
Okay, then we'll go to the next question. You can see similar question we solved at the beginning of this class.
Yes, sir.
So there is some circuit and the question is determine the power delivered by the voltage source. There is one voltage source, 32 volt. Okay. As usual, we will start with 0 volt here. So means we assume that to be 0 volt. That means potentials of all other points are measured in with respect to that. It doesn't matter. You can take any other point as 0 volt, but if you take 0, it's easier to solve the circuit because if you write 0 here, instantly the voltage of another node is known. But if you write 0 here, maybe somewhere else, say if you write 0 volt here, you do not get to know the voltage of another. You get actually here 27. Anyway, whatever. There is a convention, but you can take anywhere else, so it doesn't matter. All right. So if that is 0 and that is Vy, then we have here Acha, we already know some things, right? Vy we know. You see 4 ampere current is flowing and it is dropping across this 6 ohm resistance. So this is 24 volt. And similarly, this is 27 volt. And then this is 24 plus 32. 56 volt. Then what is the current flowing in this direction? The current flowing in this direction is 56 minus 27 by 2. It is 29, right? Yeah, 29 by 2. And the power associated is 29 by 2 times 32, that is 29 times 16. Some value you will get. 29 times 16, 464. Hey, 1 minute. Answer is not matching. Oh no. No, I wrote it correct.
18. 9.
I am getting 464. That is not here. Did I do a mistake? Oh, I made a mistake. Sorry. Sorry, it's completely wrong. Can you tell me why is it wrong? You see, this is 0 volt, but this voltage you do not know. There is some voltage drop across the current source. This we do not know. If this is V, this should be 24 plus V. Right? There is some voltage drop across the current source that we don't know. This is not 27. Sorry, it's completely wrong. 0 volt I will not. We'll start over. Sorry. Don't make these mistakes, okay?
Yes, sir.
We have to go for it. I thought it's easy problem, but it's not. Not easy problem, but same thing we have to do. So we'll start over. Node X, how much current is coming in? Let us do like that. It's Vy plus 32. So how much current is coming in? 9 ampere coming in. Hey, let us do how much is going out. It's easier to write. Minus 9 plus Vx by 5, that branch, plus Vx minus Vy by 4, the top branch, plus Vx minus Vy minus 32 by 2, the other branch, equals 0. And Y node we can write similarly minus 4 coming in. I'm sorry, minus 4 going out, plus Vy by 10 going out, Vy minus Vx by 4 going out, plus Vy plus 32 minus Vx. Tell me if you understand how I wrote the last term. Not difficult, but still if you are finding it difficult. 0. Okay. Okay. If you can write the equations, you can solve. You can find that Vx is 50 volt, Vy is 30 volt. What is the question? Okay, power. So Vx Vy we know, you will write Vx Vy. So you see Vx is 50 volt and there is a 27 volt drop here. So basically this one is at 77 volt. This one is ignored completely. That's why we had a mistake. Similarly, Vy we have to 30 volt and we have a drop of 24 volt here. So this one is at, we do not need to find this out, I'm just writing 54 volt. So you can find out how much power the current sources are delivering. And this voltage is Vy plus 32. So 62 volt. Now the power, so there is 12 volt drop, 2 ohm, so 6 ampere. So the power is 192. 192 watt. Okay.
Sir, how 6 ampere current come?
Did you understand the 62 volt?
62 volt. Yes.
This one.
Yes, sir. Yes, sir. I understand. 30, 32. Yes, sir.
So if this is 62 and this was our Vx, which came out to be 50. So 62 minus 50. So there is a 12 volt drop across this 2 ohm resistance.
Yeah, understand, sir. Okay, sir.
All right, we'll go to the next question. Same thing, but we have to now, I think, yes, we have to look at 3 nodes. Now we have Vx, we have Vy, we have Vz. Same thing. Only thing is now we have 3 variables and we should be having. So we will start 7:30. Okay. So how much current is going out? Vx. So this is 0. So this is 30, no doubt. And this is 14. So Vx minus 30 by 3 plus Vx minus, okay, Vy by 4, and this one we have to write for the top branch. So if this is Vz, then this is Vz minus 4. So Vx minus Vz plus 4 by 2 equals 0. This is one equation for x. For y node, we have how much current is going out we are writing. Okay, so minus 4 plus Vy minus Vx by 4 z node, we will write how much is going out. So Vz, okay, Vz minus 14 by 1 plus Vz minus Vy by 6 by 2 equals 0. Tell me if there is any doubt or mistake. If we have this, then by solving we should be able to get Vx equals 24 volt, Vy equals 32 volt, Vz equals 20 volt. Now what is the question? Question is, okay, one more thing is, do not have this habit of solving the circuit completely and then look at the question. Okay, since I have practiced this question before, so I know that I have to solve. But in competitive exam and all, many times some question come for which you do not have to solve the whole circuit, so do not waste your time. See if you can answer the question without solving the whole circuit. Okay, all right. How much is it? Okay, what is the question? Current, power delivered by the current source. So we have to find out this voltage. This voltage. So what is Vy? Vy is 32 volt. 32 volt, and 4 ampere current is flowing through this 5 ohm resistance. So this must be 20 volt. So if this is 20 volt and the total is 32 volt, this has to be 12 volt. So the power delivered is power delivered is 48 watt. Did I do some mistake? Oh, see, I made a mistake here. Current is flowing in this direction. So the voltage drop is in this direction. In this way, it is 20 volt. In this way, it is 20 volt. So it should be 32 plus 20, 52. You got it where I made the mistake?
Yes, sir.
Okay. So this kind of mistakes you should not do. I am doing also in
Yes.
your exams. So do it carefully. Current is going from bottom to top. So the voltage drop in the 5 ohm resistance should be in this polarity, 20. So if this is 0 volt and this is minus 20 volt, so that is 32, that is, and this one is 32 with respect to the ground, this Vy. and this point is minus 20 with respect to the ground, so the voltage drop is 32 minus 52, 20 minus 20. So 32 plus 20 is 52 in this direction. So power output is 52 times 4. Easy question, but still making mistakes. Anyway, I'm not appearing for GET. You guys are going to appear, so be careful. Okay.
Yes, sir.
So remember where I made mistakes. So you guys don't make mistakes there. All right. Same question. I told you this section will be boring. Determine the amount of power delivered or received by the current source in the circuit shown in figure 8. To say the equation, you tell me, I will write. But do not write and then tell. You tell directly. Look at the circuit. I have written Vx and Vy. Now tell me the equation. Node equation at node X. Tell me. Anyone?
Vx upon 2.
Vx upon 2. So you are talking about how much current is going out. Okay. Then
Vx minus 20 upon 2.
then
Vx minus Vy upon 10.
then
Vx minus Vy plus 6 upon 5.
this is not a voltage source.
minus 6.
Minus 6. We were writing how much current is going out, right? So 6 ampere is coming in, so minus 6.
5 ampere resistance, 5 ohm resistance is
Let there
remain.
be, but 6 ampere will flow through this, no? Okay. Someone else tell me the Y node equation. Quick.
Sir, Vy minus 15 upon 3.
Is it minus 15?
Sorry, plus 15.
Yeah. Because this node it has at a voltage of minus 15 volts. So
Yeah,
Vy minus
yes.
minus 15. Okay.
Vy by 3
Okay.
and Vy minus Vx by 5
Then
plus 6.
what did you say?
Vy minus Vx by 5.
No.
That will be plus 6.
Yes, that will be plus 6. That much current is going out. And
Yeah,
Vy
I
minus
said
Vx
plus
by
6.
10. This one, Vy minus Vx by 10.
Okay, yeah. Vy minus Vx by 10.
And 6. All those currents are going out. Okay. Same thing. If you solve, we will get Vx. This time not very good looking numbers. 13.4 volt. Vy minus 12.6 volt. And amount of power delivered or received by the current source. Okay. So they have given the solution says this node is at 13.4 volt. I'm not writing the volt V. And there is a voltage drop of 30 volt here. So this point is definitely at 43.4 volt. And this one is at minus 12.6 Vy. So the voltage drop across the current source is 43.4 minus 12.6, which becomes 50, 55, 56. So the power is delivered. As you can see, current is exiting the higher potential terminal. So it is okay. Any doubt? No doubt.
No,
Here we
sir.
go. Yeah. You said hello, sir, or no, sir?
No, sir.
Okay. I thought we will take a lot of space for this question. We would if I had to solve the equations, but I am assuming you can solve the equations, the linear equations. Okay. Same thing. There is some 6 watt resistor somewhere. This one. We have to find out the power absorbed. So there are 3 nodes here, right? This one is Vx, this one is Vy, and as I said, Vz. This is one node. If this is Vz, this is also Vz. Tell me the equations.
Vx minus 24 upon 2. Vx minus Vy upon 3.
Okay.
Plus Vx minus Vz upon 6.
Okay. That's all right. Okay. Someone else tell me the Y node equation. Y is very easy. Tell me.
Vy minus 3.
Once again, I couldn't hear you. Vy.
Vy minus Vx by 3.
Yeah.
Vy minus Vz by 4. And
And
Vy by 5 equal to 0.
all right. And someone else tell me Vz. How much current is going out of Vz? You see one thing, as I said that whether I write Vz here or here doesn't matter. But writing Vz on the right hand side is easier. Why I say easier is if you write Vz here and try to write node, question comes to your mind how much current is flowing here because 8 ampere is being distributed. But the same thing, same effect, if I write Vz here, I know that for this node 8 ampere is coming here. Okay. Okay, now I have written Vz here. Now you tell me the equation. Go ahead and tell me the equation. Someone. How many students are there? I didn't check. Are there only two?
Vz minus Vy upon 4.
Vz minus Vy upon 4.
Vz minus Vx upon 6.
And
Vz upon 1
and
plus 8.
plus
8
plus 8 or minus 8?
minus 8.
Which one? Plus or minus? See, when you say Vz minus Vy by 4, what current is that? Is that current leaving the node or coming to the node?
Coming to the node.
No, this is Vz. You said Vz minus Vy by 4, so that current is leaving the node.
Yes, sir.
Similarly, Vz minus Vx by 6 is also leaving. Vz by 1 is also leaving, whereas this 8 ampere is coming in, so we have to write it minus 8.
For leaving, we use minus sign.
Sorry?
Yes, yes, sir.
Is it clear why it is minus 8? Why not plus 8?
Yes, if leaving node, then minus use, incoming node plus use.
No, not like that. If leaving, then not like that. It's about how you are writing. From the very beginning, I could have written the equations as currents are coming to the node. I could have written Vy minus Vz by 4 plus, see, all these currents are coming. Vx minus Vz by 6 plus 0 minus Vz by 1 plus 8 equals 0. Aha. Here it is plus 8. If you are adding them up, then all the current should be either coming towards the node or going away from the node. You cannot mix them up.
Okay, sir.
Okay. Now, if you see these things, these concepts get cleared only when you talk in the class. When you solve, you get very bad numbers. Oh, sorry. Vx absorbed by the 6-watt resistor. So power is V square by R. So V square by 6, and V is Vx minus Vz. So 16.992 minus 9.54, sorry, 454. This is the voltage across the 6 ohm resistance, right? Vx minus Vz, or whatever, Vz minus Vx also you can write. At the end you are squaring it up. So by 6 V square by R, whatever you get, that is the answer. Should be somewhere around 9.47 watt. Okay. Any doubt?
No, sir.
Go to this question. My goodness. See, This is a clear indication of a loop. We have to apply mesh here. How many more do we have? One more. This one I will do later. I do not like loop. Means at least for today. We were solving same type of question. We will complete this. Then we'll go to that question. In the circuit shown in figure 11, determine the total power delivered or received by the current sources and voltage sources. Okay. All right. So 3 nodes we have. Vx, Vy, Vz. I will quickly write the node equations. You guys tell me, check if there is any mistake or something. I will write all of them assuming current is going out. Okay, you tell me one thing. Do I need to take Vx, Vy, Vz?
Sir, again say I cannot hear.
Do we need to take the 3 variables here? Vx, Vy, and Vz?
No, sir. Two variable
Because
needed.
this is the 35 volt we have, and there is no impedance in this path.
Yes, sir.
So
Only two variable.
yes, that will be enough. So if I take, say, those two as Vz and Vy, I can simply write this as Vz plus 35. We can do this with 2 variables. Why unnecessary? Anyway, we couldn't even write the equation also without. All right. So if we have this, then we can write the node equation only at 2 nodes, Y and Z. So Y, if I write the node equation, what I have, how much is going out? 18 going out. Going out. One equation. And for Z, I will write how much is going out. So minus 12 plus. We have a problem here. We do not know the current in that one. So we have to take another variable, I think. Let us see. So Vz minus 30 by 5. This is minus 12 plus Vz minus Vy by 15. But in this top branch, there is no impedance. There is no impedance. So we have to assume some current. We were assuming currents going out. So I will assume some current, say I naught, going out. I thought I avoided one variable, but I did not actually. So we have to now find out another equation. Can we find out another equation? If I naught is coming this way, Probably this thing is called super node. No need to be get intimidated with that name. Wait a minute. So no, that will also not help us. Can you suggest any way? Any other equation can you see somewhere? Or can we locally solve something? See, we can locally solve a circuit. Look here. Suppose this is I1. See, if this is I1, then this is how much? I1 minus 18. Right. Now you can apply KVL in the top loop easily because there is no resistance in the top loop. So you can simply write 35 equals 12 times I1 plus 15 times I1 minus 18. So that gives you how much? So 27 I1 is equal to, okay, I have to do this, 35 plus 15 times 18 is how much? 305. And that divided by 27 gives us something 11.296. Can you check once if I did it correctly? I assume the current I1 here, and since we know the current 18 ampere is going this way, I know that current here is I1 minus 18. Now I apply KVL here. So the KVL gives me 35 is equal to 12 times I1 plus 15 times I1 minus 18. So 12 plus 15 is 27 I1, and it is 35 plus 35 plus 15 times 18. Yes, 35 plus 15 times 18 gives us 305. That divided by 27 gives us 11.296. Okay, so we could solve something locally. Some parts we could solve locally. Let us see how much we can go ahead with it. If we could find out I naught, that would have been easier. Okay, anyway. So this is 11.296 ampere. So this minus 18 is 6.7. So 6.704 is coming this way. So they together make it 18 ampere. And 12 ampere was coming this way. Can we say anything else? Yes, we can find out the voltage and find the relation between Vx, Voe and Vz, I think. So we will write down the no, this is also known. Some more thing we have to do. We cannot yet find I naught. But some of the come on, give me some idea. I'm out of ideas now. 24 ampere goes, this goes out, I naught comes. Looks like we can apply a KVL here. Oh no, we cannot. There is a voltage source, current source. These voltage also we do not know. Goodness, how to do this? This is going to be the last question for today, but we have to solve this anyway. Do you find an easy way? Okay, I think we can write one more equation. We'll write the node equation here. Let us see. Let us call this node as X. Now, if I call this node as X, what we have is how much current is going out. So minus 24 is going out, plus 11.296 is going out, plus Vz plus 35 minus 20. So Vz plus 15 by 4 is going out. Okay. And minus I naught is going out, 0. So we have three equations, three unknowns. Vz, Vy, and I naught. These three unknowns we have, and we have three equations. We can solve this, and if you solve, we will get solution. I told you, we will get Vz as 45 volt, Vy as minus. Can you guys solve this and let me know next day whether it is correct? These equations and all, if they are correct. And Vx will be that plus 35. So 80 volt. Okay. Now, if that is all, what we can do is, since we have to find out the power of all the equation, all the things, okay, I naught we have to find out. I naught will be 2.296 ampere. If you just substitute things here, you will get. You definitely do this, at least solve the equations and let me know next day, okay? Whether you are getting these results. If not, we have to do it once again. Somehow they removed the resistance here and the problem became a bit more difficult. All right, we'll quickly see whether we have all the data. So voltage at this node we know 80 volt, and there is a 48 volt drop here. So this is 128 volt. So we can find out power of this voltage current source. If this is 80 volt, then we can find out the current. It is 15 ampere. I'm no sorry, not in this direction. 80 volt, 20 volt. So 15 ampere. So see, this one is absorbing 300 watt of power. This voltage source. Okay. Vy we know minus 55.5 volt. So this is also absorbing power. No, not absorbing power. This is at higher potential. Delivering power, but we can find out the power because we know the current and voltage. Okay, this is done. Vz we know 45 volt. So 45 minus 30, 15, 3 ampere is coming. So we can find out minus 90 watt of power is being absorbed by this thing. And I naught you can solve this and tell me 2.296. So we can find out power for this one also. Last one is this 45 volt plus 72 volt. So 117 volt. You can find out the power for this also. As of now, any doubt here? Or you want to solve and then respond?
No doubt, I am solving now.
Okay, you take a screenshot of what you have right now on the screen. Write the equations once again and then solve the equations and then see whether you are getting the same thing. Is there an easier way to do this? I don't know, we have to see. Okay, we'll stop for today then. Next Monday we'll meet you do this and let me know. Next Monday we'll have an interesting discussion on voltage source and current source at the beginning. Let us see if we can. All right then, goodbye.
Thank you, sir.